Hey guys, this is Coach Lowe, and we're going to talk about deductive reasoning. This is section 2.4. A few notes that you need to take for today. So deductive reasoning, there's a difference between inductive and deductive reasoning. We've looked at inductive reasoning this year already. Inductive reasoning is when you're looking at a pattern, and you guys just had a quiz on that. You're looking at a pattern and trying to figure out the next term or the logical flow of it, of the situation. Deductive reasoning is a little bit different. Deductive reasoning, it uses facts, definitions, rules, properties to come to a logical conclusion from given statements. So let's look at this first one. Every time Hunter braids her hair before a basketball game, the team wins. Hunter braids her hair before tonight's game, so she concludes they will win. That is inductive reasoning and superstition also. I mean, let's just call it what it is. All right, look at number 2. Paul knows if he's late returning a movie, he'll be charged a late fee of $1.50 per day. Paul is one day late returning a movie, so he concludes that he will be assessed a late fee of $1.50. That is deductive reasoning. Excuse me. Reasoning that's based on facts. He already knows this is going to happen. The situation arises. He knows what the conclusion is going to be from that. All right, so let's look at some ways that we can validate arguments or tell if an argument is logically correct. One of those ways is the law of detachment. The law of detachment says if P implies Q, and remember these are statements, is a true statement and P is true, then Q is true. All right, so let's look at this first example and kind of walk through it. And I'm just going to make some notes over here. I like to think about it looking like this. If P implies Q, P is true, then Q is true. And that's those 3 dots mean therefore. All right, so let's look at example 1. If a triangle is equilateral, then it is an acute triangle. A triangle is equilateral. So this is the hypothesis, this is P, implying the conclusion, or Q. All right, so we have if P, then Q, or P implies Q. The next one, and we don't need this if in the front really, the triangle is equilateral, that is P. And our conclusion is, therefore, the triangle is an acute triangle. So this is the law of detachment. The conclusion is Q. It is an acute triangle. All right, let's look at example number 2. If a figure is a square, then it is a parallelogram. So P implies Q. All right, so remember what we're looking for. P implies Q, and then we're going to make the statement about the conclusion, and then, the statement about the hypothesis, the first part, P is true, therefore Q. All right, so let's look at this next part. The figure is a parallelogram. Oh, wait a minute. So we have P implies Q, then we have Q. That is not the law of detachment. So this is not a valid argument. So we would just say, this is actually an invalid conclusion. And here's why. Check this out. Remember, to show that something is invalid, you need one counterexample. So it says the figure is a parallelogram, and then therefore the figure is a square. Well, it could be a rectangle, right? So not necessarily true on that one. All right, so let's go back and kind of walk through. So we want if P then Q, P, make the statement of the hypothesis, therefore the conclusion would be true. All right, law of syllogism. So this is kind of that transitive property you probably looked at in Algebra 1. If P then Q, if Q then R. And so if those are true statements, then P implies R. So P implies Q, Q implies R, then, and if those are true, then P will imply R, and that's a true statement. So let's look at the first example. If Jamal finishes his homework, he will go out with his friends. So there's P. If this happens, then he will go out with his friends. Now notice there wasn't even a then there, but you can see one implies the other. If Jamal goes out with his friends, so we already said that was Q, then he will go to the movies. That's a different one this time. So that's R. So we have P implies Q, Q implies R, So what would the conclusion be if I use the law of syllogism? So you can think about that for just a second if you want to. All right, so logically would follow that if Jamal finishes his homework, then he will go to the movies. All right, so there's P and there's R. So if he finishes his homework, then he is going to go to those movies. Awesome sauce. All right, let's keep rolling with this. Look at example number 2. If you interview for a job, then you wear a suit. If you interview for a job, you will update your resume. So we have if P, then Q, if P, then R. Same statement as here. That's a problem. That is not law of syllogism. Law of syllogism goes from the conclusion that's here becomes the hypothesis in the next statement. So the conclusion from the first statement, notice, should be the hypothesis in the second statement, and that does not happen. So this is an invalid argument. All right, so this is invalid. We don't need to go any further from there. All right, so now it's your turn. Law of detachment or law of syllogism, you decide. So you can pause the video and try these out, and then we'll come back. All right, so the first one, if a figure is a rhombus, then all sides are congruent. Figure ABCD is a rhombus. All right, so we have P implies Q, and then they made a statement here, which is P. So this is law of detachment, therefore Q. So law of syllogism has two sentences, but you're comparing three things, P, Q, and R. Law of detachment, just two. So the rhombus and all sides are congruent. So my conclusion is that all the sides of A, B, C, D, all the sides of this rhombus are congruent or are equal in measure. All right. Let's look at the last one here. Opera singers like classical music. If you like classical music, then you enjoy the opera. All right, so we have three things going on here. So if P, then Q. If Q, then R. All right, so my conclusion is opera singers enjoy the opera. All right, and this is law of syllogism. So this was law of detachment, this was law of syllogism. All right, guys. Hope you have a great day, and I will see you soon. This is Coach Lowe, and I'm out.